Welcome back to part 2, callbacks. In this part, we'll examine how functions can call other functions, as well as treating functions as variables and parameters being passed to other functions. We'll also take a look at anonymous functions, functions without a name, and give a brief preview of asynchronous computing. Functions are very versatile. Often we would want functions to be able to call other functions. The way that this works in detail is that when a function is called, control flow is handed over to that function until it completes. Once it completes and returns a value, control flow is then handed back to the calling function. These function calls are usually referred to as synchronous because they execute one after the other. For example, we've got two functions, foo and bar here. When we invoke foo on line 11, control is handed over to the function on line 5. It then invokes bar on line 6 with a value of 10, at which point control flow is then handed over to the function bar, and it simply prints the value. After it's done executing on line 3, it returns control back to line 7, where it prints out foo. Then it invokes bar again on a different value, 20, and it prints it out again on line 2. The control flow is then handed back to foo, which is now done computing, and normal execution resumes. Let's take a look at this thing in action. When we execute this code, control flow will dictate what gets printed at what point. When we invoke bar from foo, that will get executed before continuing with the execution in foo. So it'll print out bar is equal to 10 before it prints out foo. Then it'll print out bar is equal to 20. As we've seen previously, variables can hold numbers, strings, objects, or arrays. In JavaScript, variables can also hold functions. A function's value is its name. This allows us to pass a function to another function as an argument without that function actually being invoked. Let's take a look at a quick example. Here we've got a function foo and a function bar. Bar takes two arguments, a value x and some function as a parameter value. We can create a variable called myfunc and set it equal to foo. This variable is actually holding the function foo as a value rather than a traditional number or string. We can then invoke bar by passing in that variable, myfunc, or we can pass the function foo directly. When you do something like this, the passed function is usually referred to as a callback. This allows us to write more generic general code. For example, when we looked at loops, we looked at the for each function. You can pass a callback to it. jQuery has something similar with the each function. Another example would be sorting. Suppose that we wanted to sort an array of numbers. We would have to write one sorting algorithm. Well, now suppose that we want to sort an array of numbers in descending order rather than ascending. We would have to write yet another sorting function. What if we wanted to write a sorting function for a set of student objects? We would have to write yet another sorting function. To solve this problem, we write one sorting function that takes a comparator, which is a function, a callback, that can be used to order two elements. We'll see this in detail later on. Callbacks are also extensively used in jQuery. You can call a function and provide another callback that you want to be invoked after the completion of the function. Let's take a look at a concrete example. Here we've got a function foo that takes an element x and simply prints it out. We've also got a function bar that takes a value x and another parameter called SumFunction. Here it's expected that SumFunction is a callback function that can actually be invoked. In the function bar, we simply print out x and then we invoke SumFunction on x. To call bar, we would need to pass a value x, 10 in this case, and a function name as a callback. The way that this will work is that bar will print out x, bar is equal to 10, then it'll invoke SumFunction. Since we passed in foo as SumFunction, it'll end up invoking foo, and it'll print out x is equal to 10. When using callbacks, if the only purpose to a function is to pass it off to another function as a callback, there's really no need to pollute the namespace by declaring the function with an actual name. Instead, as an alternative, what we can do is define the function in line without a name so that we can immediately pass it to another function. This is referred to as an anonymous function because the function has no name. And outside the function that we pass it to, it can't be invoked. Here's the same example from before. But instead of passing foo as a function, we pass in an anonymous function here. The function has no name. We simply use the keyword function. It takes a value x and simply prints it out. Now when we invoke bar, the same behavior is observed, but there is no foo function anymore. Some functions may execute long-running procedures, such as making a network connection to get some data on a remote server. We don't want these processes to freeze or block the rest of the application. For example, clicking a button to load more data in a table. You wouldn't want the rest of the application to freeze while the data was being loaded. It would be bad for the user experience. The solution is to make some functions asynchronous. That is, that the execution doesn't block the rest of the application. Instead, it runs in the background. We won't go into detail in this module, and in fact, even with the latest versions of JavaScript, our ability to do asynchronous computing is very limited. However, we do need to understand the basics here to avoid some common pitfalls. Care needs to be taken to be able to chain callbacks appropriately, so that we can get the effects that we want. Let's take a look at an example. Consider the following example. Here we have a simple page that has a Husker logo. The image has an ID of logo. The foo function selects that logo and hides it slowly. It then attempts to show it again. Let's see what happens when we actually invoke this function. It hides it slowly, but then it doesn't end up showing it. Let's reset it. Now let's look at the function bar. Bar also hides it slowly, but in addition, instead of calling the show function immediately after, it provides the show function as a callback. Let's try it. Now it's hidden, but then it immediately shows again. The difference in these two functions is how they operate. The first one invokes the hide method. As it's animating, control flow immediately continues to the show. But because it's in the process of being hidden, it has no effect. In the second example, the show phase is provided as a callback that is only invoked after the first animation is done. So when we hide it slowly, only after it's done animating does the hide function then invoke the callback that it was given.